In this video, I will be going through our Chapter 11 review. Now, I assigned you guys 8 through 52 even, so I'm going to work off of the odd problems. Alright, let's begin with section 11.1. This section mainly was about vocabulary, chord, secant, tangent, diameter, center, and point of tangency, and being able to identify those. One that is not in this list is also radius. So for example, number 9, we're looking at point N right here. So the two different points that it talks about is the point of tangency and the center. So is it in the center? No. So this would be the point of tangency. Alright, 11D, that is your other point, so that one's going to be in the center. That one is the center. And line BF, be very careful with these symbols. The fact that it has the arrows is very important. So line BF is the one that keeps going all the way through, and that would be a secant. That one is a secant. The fact that it keeps going, it's the line. A secant is a line, whereas a chord is a little bit different. Alright, moving on to 11.2. In 11.2, we were talking about tangent lines. So keep in mind, a tangent line, it does not pass through at 2 points like a secant. So a secant passes through and hits the circle at 2 points. A tangent line, it just touches the circle at 1 point. And one of the properties was that if you have a radius, so right here I have radius CB, and a tangent line at point B, that's your point of tangency, the radius is perpendicular. The radius is perpendicular to the tangent line, at the point of tangency. Alright, so that means those two lines intersect. So that means it forms a right angle and a right triangle. So you can use the Pythagorean theorem to figure out what the radius is. So I'll do number 15. Alright, I'm going to set up using the Pythagorean theorem with the two legs, r squared plus 24 squared equals 26 squared. And I need to go ahead and solve for r, which means I have r squared equals 26 squared. I subtracted 24 squared from both sides. And then in order to get r by itself, I need to take the square root of both sides. So the square root of 26 squared minus 24 squared. And I can type that into my calculator. And I would end up with the square root of 100, which means the radius is equal to 10. Another thing that I know about tangent lines is if I have a point, so let's look at number 19 here. If I have a point A, I can draw two tangent lines to the circle, and those two tangent lines are going to be congruent. So that means I can set those values equal. So 3x minus 4, that's AB, is equal to x plus 10, AD, and I should be able to solve for x by combining my like terms. X would equal 7. Alright, let's move on to 11.3. In 11.3, we looked at arcs, major and minor arcs. Keep in mind, minor arcs were less than 180 degrees, so less than half the circle, so they're minor, they're smaller. And the major arcs would be majority, or a little bit bigger than 180. It's everything else left in the circle if you take away the minor arc. And their relationship with central angles. What the theorem we used said was that a central angle, the measure of a central angle, was equal to the measurement of the corresponding arc. So for example here, the right angle for ECF would mean that the corresponding arc would be 90 degrees. Alright, and we're able to add and subtract different arcs in order to find other missing pieces. So looking at 21, I'm trying to find arc AE, and I know that AD is a diameter. AD is a diameter, which means that that total is 180 degrees. I should know that. And the measure of CE is 121. So if I know CE and CD, alright, that's 121 minus 59 in order to find out what DE, arc DE, equals. And that would come out to 62 degrees. Alright, so I now know that this is 62 degrees, which means that I can take that away from 180 in order to find AE. Alright, so 180, that's AE, minus 62 would give me 118 degrees. So with this sort of problem, you will be given a number of arcs that you'll have to find, and once you find a piece, I would mark it on the picture exactly what you know so that you can use those pieces. So when they give you AD, make sure you mark 180 so that you're able to use the information you already found. So I found 62, and now I know this is 118, so I should be able to figure out CB. It's the only other arc. I would be able to add all those pieces up and take it away from 360 to find that arc. Alright, moving on to one like 27. So for the record, 118 is your answer for that. For 27, we need to actually find the length. So there's a difference between finding the measure and finding a length. If you recall, this is probably the most complicated math you'll have to do. You need to set up a proportion. So I have my central angle, so it's the small piece, that small angle that we have, over 360. So I have a part over a whole, and then I have the length that you're trying to find, so the red arc, over the circumference, which is, I'm going to substitute 2 pi r in for circumference. Alright, so this is our general formula. It's part over a whole, part over a whole. So my central angle, looking at 27, my central angle is 120 degrees over 360. And I don't know the length of the arc, that's what I'm trying to find, over the entire circumference, which is 2 pi r, and your radius is 8, so that's 16 pi. Alright, I do know those zeros cancel out. 12 over 36, that reduces to 1/3. X over 16 pi. And then I solve for x here by multiplying each side by 16 pi. So I get 16 pi divided by 3. And it told me to round to the nearest 100th. So my answer should come out to approximately 16.76, and it said centimeters. Alright, so I think this might be one of the most complicated problems. You'll only have one of those. In 11.4, we were told that if we have two congruent arcs, then the corresponding chords are congruent, or if I had two congruent central angles, then their chords and their arcs were congruent. So we're really just setting a whole bunch of stuff equal, but we have to know why. So let's work out 29 first. So I know that these angles are marked congruent, which means their corresponding chords and arcs, minor arcs, are congruent. So that means x plus 5 should be equal to 8, so x would equal 3. 31, let's do 31. Alright, I know that since these chords are congruent, that the angles are congruent. So that means 2x equals 70. And I would divide by 2 on both sides, and x should equal 35. Last but certainly not least, 33. Because these chords are congruent, I have a perpendicular bisector, AB is diameter. You know all this information just by the picture. X should equal 60 degrees. And you don't even really have to solve that. It's just how it's written. Let's move on to 11.5. Here is the difference that some of you guys were getting stuck on. Inscribed angle versus a central angle. An inscribed angle means that angle is on the edge of the circle. So that arc, I did draw this for you guys before. So here's a nice example of a central angle that looks about 90 degrees. So that arc should be 90 degrees. If I draw an inscribed angle to the same corresponding arc here, you can physically see that this new angle is a lot smaller. It's exactly half the size. So here's your formula. Alright, you have the measure of that interior angle is going to be half the corresponding arc, and the measure of the arc is going to be twice that inscribed angle. So for 35 here, all I really have to do is 106 divided by 2. So this angle for 35, measure of angle ABC, is going to equal 53 degrees. And for 37, I'm trying to find the measure of that arc, and so I know the measure of arc ADC, keep in mind your order does matter here, it's going to be twice that, so that is 100 times 2, or 200 degrees. Alright, and then some fun information, additional information 11.5. They tell you that with right triangles that are inscribed, which means they're drawn inside of a circle. Oh, that's pretty bad. Right triangles, the hypotenuse is a diameter. So that means the opposite angle is always 90 degrees. Also, in a quadrilateral that is inscribed, the opposite angles, that means angle A and C here, angle A plus angle C, they are supplementary, which means they add up to 180. So that means for 39, I can take 180 degrees minus 81, and that'll give me angle Y. And I should be able to do the same thing for X. So that means Y will come out to 99 degrees. 11.6. 11.6, we have two more theorems. If I have two chords that intersect, so I don't have a central angle, I don't have a nice central angle, and I don't have an inscribed angle. However, this angle occurs somewhere else, so I have two chords that intersect. That's a little off center. Your center might be right there or something like that. If I have two chords that intersect, in order to find one of the angles, I take the corresponding arcs. So right here, here's the angle. X, this angle would also be X because they're vertical angles. I take the two arcs that go with those. Now you see how they're different measurements, 30 and 40. You take the two arcs and you add them together and you average them out. That means you divide by 2 or multiply by 1/2. So for 41, let's do 43, and it has one additional step. Okay, so notice this angle does not actually go with those two arcs. So here's what I'm going to do. I'm going to go ahead and plug those into my formula. Alright, I add the two arcs together, and I come out to an average of 110 degrees. So I know that this angle right here is 110. So how do I find x? Well, it's a straight line. I take it away from 180. So that means x should equal 70 degrees. And 45, this is my second theorem. It says if you have two chords that intersect, it breaks it into two pieces. We see that. Each chord is broken into two pieces by that intersection. If I take each piece of the same chord and I multiply it, so EC times EA, and the segments of the other chord multiplied, those two products should be equal. So I take one piece, multiply it by its second piece. So for 45, I need to take 8 times 10 should equal x times 16. So 80 equals 16x, x equals 5. Now last but certainly not least, 11.7. In this section, we were mainly identifying your center and your radius and being able to put in the information and pull it out as well. So here's our formula. X minus h squared plus y minus k squared. And that should equal r squared. So do not forget your squareds, don't forget your minus signs there, adding in the middle, and that your radius needs to be squared. There's going to be problem areas. Make sure you have all the pieces. And I told you guys that on the inside, if it reads negative, that means your h and your k, that's your center, are actually positive. And you'll be looking for your radius as well. So let's do 47. So 47, if I just plug all that information right there into the formula, I should get x minus 2 squared plus y minus 5 squared equals 3 squared. Go ahead and take this step and actually square the 3 and get 9. Alright, and that is your standard equation for your circle. For 49, there is one little piece that's different right there, and that's that minus sign. So you're still going to have x minus 5 squared plus what happens when you subtract negative 2. You actually get y plus 2 squared and 7 squared, and go ahead and square it, and you get 49. So I need to be able to work it forwards, and I need to be able to work it backwards, like 51. 51, if I'm pulling out the information, I have a minus 2, so that means it's actually a positive 2. A plus 3, it's opposite on the inside, so that's actually negative 3. That's my center. And then my radius, r squared equals 16, r squared equals 16, so r should equal the square root of 16, r equals 4. Alright, please see me in the morning or email me with questions. Good luck studying.